types of sets. Now, sets may be classified according to number of elements in them. So you see, the number of elements in a set will show you the type of set. Now let's start with the first type called a finite set. So number one, I want to look at finite sets. Now with finite sets, we are talking about a set whose last member can be found is referred to as a finite set. So that means that if you have a set, let's say a set A, and then you can boldly say that it's 1, 2, 3, 4. You realize that this will be the only members of the set. Now, once 1 is starting and 4 is ending, then this set can be described as a finite set because the last member, which is M, or the last element, which is M, is known. So this set can be a finite set. Now, the next type of set is infinite set. Now, infinite set on the other side will be a set whose last member is not known. From the beginning, once we know that last member is finite set, and then the last member is not known, will become infinite set. That means we are going to use the 3 dots. An example of infinite set is, let's say M, which is equal to 1, 2, 3, 4, 5. 1, 2, 3. That is the 3 dots. So if you get the 3 dots there, it means that it becomes infinite set. So this one means, and so on. So you can go until infinity. So these are the members of the set, but the last member of the set is not known. So this cannot be a finite set, but rather it is called an infinite set. Now let me warn you on this. Let's give another set, let's say M. And then let's get a set 1, 2, 3, 7, 8. This is not an infinite set, but rather it is a finite set. Now the fact that I have omitted members doesn't make it that the last member is not known. The last member actually is 8, but there is an omission along the line. So once there is an omission along the line, it doesn't make it infinite. This is a finite set because the description of a finite set is a set whose last member is known. And once this set M has a last member of 8, set M becomes a finite set, but rather not an infinite set. Next set will be a null or an empty set. Now, a null or an empty set is a set which has no member or element in it. So if you have a set and there is no member or no element in it, then you can call it a null set, or you can also call it an empty set. Let's take a set B. Then we write this. Now you should realize that there is no member in the set B. Once there is no member, it becomes a null set, meaning it is an empty set. Also, let's take the set C. And then if we put this in there, when you do this, it will become a single set because there is something in there. So you don't have to represent it this way, but rather this is the best. Or you can say C is equal to, you write your 0 and you cancel. So either this one or this one, but this one is wrong. So this is what we call null set, but this was a unit set, or maybe this one has a set with one member. So you have to take note of how you represent your null set and know that a null set has no member in it. So the null set is what we refer to as an empty set. Let me give you an example. Let's say I have M and I have equal to, I have the curly bracket and I put 0 in there. Also, this is not a null set because the member in there is 0. The fact that there is 0 as a member doesn't make it a null set. It makes it rather a unit set. That is a single member in there becoming one member. So it's a unit set. That brings us to the new type of set called unit set. Now a unit set is any set with only just one member. Yes, one member. If you have a set K and then you have even 0 as the member, this will become a unit set. You can talk about set P, and maybe you have like something like 25 as the member. This becomes a unit set. So a unit set is any set with only one member, just one member. That is what we refer to as a unit set. The next type of set will be the universal set. So the universal set will be a set under which all the other sets are described. So it is the set of all objects under discussion. So whatever we are discussing must fall under one set or one umbrella. And that set is what we call the universal set. So a universal set must have a symbol U or this symbol. So the two of them can be the symbol for universal set, or universal set can be denoted as U or this. So that is a symbol for universal set. So we take note of that. Now, if you want to give example of universal set, let me take shapes to be the members of the universal set. So plane figures such as triangles, maybe the quadrilateral. Now, if you take triangles, they are three-sided figure, and quadrilaterals are also four-sided figures. These two members in a particular set will get their universal set as polygons, because polygons actually talks about what we call all shapes. So the number of sides of the shape will give the name of the polygon. So if I call a polygon a triangle, it is a polygon with 3 shapes or 3 sides. And if I call a polygon quadrilateral, it's a polygon with 4 shapes or 4 sides. So if a triangle and a quadrilateral is found in a set, then the universal set for that particular set is going to be a polygon. So that is what we describe when we talk about universal set. The next type of set is what we call the equivalent set. Now, 2 sets are said to be equivalent if the 2 sets have the same number of members. So please note that you cannot say equivalent when you don't talk about the number of members in that set. So equivalent sets have the same number of members in a set. So for example, there are set A, which have the members 1, 2, 3. And I have set B, with its members 11, 12, and 13. Now you realize that the members are not the same in terms of appearance, but the number of members in set A. Number of members in set A will be 3 members, 1, 2, 3. And the number of members in set B will also be 3 members. So if we have 3 members in set A and then we have 3 members in set B, then we can now describe these 2 sets as equivalent sets. So equivalent sets are sets which have the same number of members in them. So that is what we call equivalent sets. So take note of that. Now we come to the last one, which is equal set. With equal sets, we don't talk about the number of the members of the set being the same, but 2 sets are supposed to be equal if they have the same members, that is same appearance of members. Let's take a set M, which is having, let's say, 3, 7, 8 as the members. Then we take the set N, which also has 8, 3, 7. Now if you check, the members in set M are 3, 7, and 8. And then the members in set N are also 8, 3, and 7. Comparing them, they have 7 in there, 7 in M and 7 in N. We have 3 in M and 3 in N and 8 in both, that is M and N. So in view of this particular appearance, we can talk about the fact that the set M and the set N are equal sets. So equal sets finally will be the set with the same members. Even though the number is the same, but you see the appearance of the members are the same. Unlike the equivalent set that their appearance are not the same, but their number is the same. With the equal set, the members in there will be the same members in the other set. So that makes the 2 sets equal sets. To describe equivalent in terms of its symbol, we can say A is equivalent to B. So we use 3 lines to show the equivalence. And then if you want to make it equal, we say M is equal to N. That shows equal and equivalent. So remember, equal with 2 stripes making the equal, and equivalent with 3 of them making it equivalent. Thank you.